Today I will discuss about the design of 4-bit arithmetic circuit. Before discussing it, let us continue with the arithmetic microoperations. Arithmetic microoperations perform arithmetic operations on numeric data stored in register. The basic microoperations are addition, subtraction, increment, decrement, etc. So, first I want to discuss about the arithmetic addition microoperation. So it states that the contents of register R1 are added to the contents of register R2 and the sum will be transferred to the register R3. To implement with this statement with hardware, we need 3 registers. So one is R1, another is R2 and the third one is R3. So basically what will happen? The contents of register R1 will be added with the contents of register R2 and the resultant will be stored in the register R3. The next operation is the subtraction operation. Subtraction is most often implemented through complementation and addition. So here this is the subtraction operation with the help of the complement and addition. So first in this subtraction operation, this states that the contents of R1 minus R2 is transferred to R3. Next one is complement the contents of R2. It is basically 1's complement. This is the 2's complement. It indicates that contents of R2 plus 1. That is the 2's complement of R2. Next, the subtraction operation. So basically what happened here? R2 complement is the symbol for the 1's complement. So here, when we are saying that it is R2 complement is nothing but 1's complement of R2. 1's complement of R2. Okay. So adding 1 with this. Adding 1 with this means adding 1 with 1's complement will produce 2's complement. Okay. So it will produce the 2's complement. And it is equivalent to R1 minus R2. That means adding the contents of R1 to the 2's complement of R2 is equivalent to R1 minus R2. And after this, the resultant will be stored in R3. Next operation is increment and decrement operation. The increment and decrement microoperations can be symbolized by plus 1 and minus 1. So it indicates increment the contents of R1 by 1 and this microoperation indicates that decrement the contents of R1 by 1. So the increment and decrement microoperation can be implemented with the help of combinational circuit or with binary up-down counter. So these microoperation which are listed in this table can be implemented in one composite arithmetic circuit. So the basic component of this arithmetic circuit is parallel adder. By controlling the data inputs to the adder, it is possible to obtain different type of arithmetic operations. So the diagram shows 4-bit arithmetic circuit. It has 4 full adder circuit that constitute the 4-bit adder and 4 multiplexer for choosing different operations. There are 2 4-bit inputs A and B and a 4-bit output that is D. So what are the 4-bit input? 4-bit input is basically A3, A2, A1, A0. This is one 4-bit input, and B3, B2, B1, B0. This is another 4-bit input, and the resultant will be stored in the output D, that is nothing but D3, D2, D1, D0. So here A0 is LSB and A3 is MSB. This is MSB. This is LSB. Similarly here this is LSB. This is MSB. Similarly here this is LSB. D0 is LSB and D3 is MSB. Okay. So there are two 4-bit inputs A and B and a 4-bit output D. The 4 inputs from A go directly to the X input. See that the input from A0 goes directly to X0. Similarly, from A1 it goes directly to X1. A2 it goes directly to X3. A2 will go directly to X2. A3 will goes directly to X3. Okay, so the 4 inputs of A will go directly to the X inputs of the binary adder. Each of the 4 inputs from B are connected to the data inputs of the multiplexer. Okay, this is connected to the multiplexer. These inputs are connected to the input of the multiplexer. The multiplexer's data inputs also receive the complement of B. This is B. This will be B complement. So in the logic, the 0, D0, if we consider it data 0, it will take the B input and it will take the B complement input. Okay. So each of the 4 inputs from B are connected to the data inputs of the multiplexer. The multiplexer's data input also receive the complements of B, and the other 2 data inputs are connected to logic 0 and logic 1. Logic 0 is a fixed voltage value, that means logic 0 is basically 0 volt. Okay. Logic 0, it is 0 volt. And another is logic 1. That is nothing but 5 volt. So logic 1 signal can be generated through an inverter whose input is 0. That can be logic 1. So its input is 0. If its input is 0, its output is 1. So here, if the input is 0, output is 1. So one input is 0. That will go to D2 input of each multiplexer. And the 1 will go to D3 input of each multiplexer. So according to the selection input S0 and S1, the input will be selected. So the 4 multiplexers are controlled by 2 selection input, that is S1 and S0, where S1 is MSB and S0 will be LSB. So the input carry in, Cin, will go directly to the, actually the input carry goes to the carry input of the full adder in the as the least significant position. The Cin is the carry input. It is connected to all the full adder. So actually what happened? This C0, this Cin will be connected to the first full adder, and then its carry will be added to the second full adder. Okay. So the all other carry is connected from one stage to the next. Okay. So from first full adder, C1 will be connected to the next full adder. C2 will connect it to the next full adder. C3 will be connected to the next full adder. So first full adder, that is C0. So next each full adder will be connected to the next stage. Okay. So the output of the binary adder will be calculated by the help of the expression D equal to A plus Y plus C in, where A is the binary number at the X inputs and Y is the 4-bit binary number at the Y inputs of the binary adder. Cin is the input carry, which can be either 0 or 1. So by controlling the value of Y with the two selection inputs S1 and S0 and making C1 equal to 0 or 1, it is possible to generate 8 arithmetic microoperations. Suppose the selection line is 0, 0 and Cin is 0. So our input is B. So this will perform the addition operation A plus B. Next, if Cin is 1, then it also will perform the addition operation. But in the first case, that is with carry. And the second, in the first case, that is without carry, because in Cin that is 0. So it is basically without carry, addition operation without carry. And the second one is the addition operation with carry. When S1 and S0 are 0, 1, then the complement of B is applied to the Y input. Okay. So then the complement of B will be applied to the Y input. And if the Cin is 0, that means subtract with borrow. And if Cin is 1, it is nothing but 2's complement addition. So it is the subtraction operation. Similarly, when S1 and S0 is 1, 0, the inputs from B are neglected and instead all zeros are inserted into the Y inputs. The output becomes D equal to A plus 0 plus Cin. So when Cin equal to 0, it is nothing but D equal to A. And when Cin equal to 1, it is nothing but D equal to A plus 1. So when we call D equal to A, that means it is nothing but transfer A. And the second case, when A plus 1, that means it is increment A. So increment A by 1. So when S1 and S0 both are 1, 1, then all ones are inserted into the Y inputs of the adder to produce the decrement operation, that is D equal to A minus 1 when Cin equal to 0. This is because a number with all ones is equal to the 2's complement of 1. If we perform the 2's complement of 1, this is the 4-bit representation of 1. Its 1 complement is nothing but 1, 1, 1, 0. So its 2's complement is 1, 1, 1, 1. This is 2's complement of 1. Okay. 0, 0, 0, 1. This is 2's complement of 1. So, adding a number A to the 2's complement of 1 produces F equal to A plus 2's complement of 1. It is nothing but equal to A minus 1. So when Cin equal to 1, then it will perform the operation D equal to A minus 1 plus 1 equal to A, which causes the direct transfer from A to the output D. So here the D equal to A, these operations occur twice. One is in case of selection line 1 0 and carry in 0, and in other case selection line is 1 1 and when the carry is 1. Okay, so this is the 4-bit arithmetic circuit. Actually here 7 distinct micro operations can be performed. First operation is addition, second the add with carry, next subtract with borrow, next subtraction, then transfer A, increment A and decrement A. Here the transfer A operation is performed twice. Okay, thank you.